In our last module, we talked about diesel engine fundamentals, how you can get more power out of them through tuning, and what you can expect as far as power gains. This module is going to go more around the software and hardware solutions and how they impact the tuning process. So what tools you're going to use to make those changes. It really comes down to commercially available versus open source or user-generated content. The user-generated content is going to be cheaper or free, but it's more for tech-savvy or hobbyist folks. So it's going to take more of your time. There's less manuals. There's less help. Sometimes there's forums, things like that, but you're going to have to fumble through it, and there's going to be a pretty steep learning curve on the user-generated stuff. On the commercially available software packages like EFI Live, HP tuners, and so on, the support is going to be a lot stronger. So you're going to have better definition support, but you're going to have to pay per vehicle. So there's, of course, going to be a licensing fee and then a software fee. In order to run that business, they're going to need to bring in cash. So, of course, the expenses are going to be up a little higher. Really, what it boils down to is how much time you have and the vehicle that you're tuning. So the older the vehicle, you can kind of favor those open source or cheaper solutions. The newer the vehicle, the more you're going to want to favor the commercial side. Newer stuff is tougher to develop products for, and usually the commercially available software packages have a better solution. At least that's what I found. Now, as you go from GM to Ford to Toyota or whatever engine you're tuning, there's going to be a group of folks out there, on the forums or enthusiasts, and they'll probably be your best source of information as far as telling you which software package is the cat's pajamas for that vehicle. So things you're going to want to consider would be how strong their map definitions are. So do you have access to all the maps that you need to have access to? Do you have good editing software as far as making edits, smoothing, blending, selecting cells? How user-friendly is that software package? And then the scanning tool. So how easy is the scan tool to use? Are the PIDs good? Can you look at good engine data? Enough to get yourself in a position where you can build a good tune file. And usually the web forums, the Facebook pages, if you talk to anybody who's been in that kind of business for a while, you get a pretty good sense of what's out there. And one last thing to consider would be custom operating systems. So different software packages and hardware packages support different custom operating systems. So if you're looking for switchable tuning, that might not be supported by HP tuners, but it might be supported by EFI Live. If you're looking for different stuff like that, different patches, things like that, there's going to be some little stuff like that you're going to find along the way. Let's open up some of these software solutions and take a look at how the maps are viewable in the different softwares. So first things first, the maps are, these softwares are graphical user interfaces, meaning that they're just showing you the data that's already in the ECU. So they're going to look similar. The tool I have open here is HP Tuners. Okay, and the HP Tuners edit software has a layout that, if you're used to using HP Tuners, is going to make a lot of sense to you. Across the top, you have these tabs, and these tabs bring you to segments of the tune that you might be familiar with. Diesel fueling, for instance. Diesel fueling would have the injector pulse width map, would have the translation for driver's wish, so pedal versus RPM. If you're used to the layout of HP Tuners and you're used to how they kind of triage and segment tables, the HP Tuners layout would be something that you're used to, right? Let's take a look, for instance, at the pedal to desired torque map. So this is a typical looking map for any of the software packages. On the left-hand side of this map is an axis going from -10 to 100, and that translation is accelerator pedal position, and you can see it's labeled here on the left-hand side. So as you push the accelerator pedal, it'll go from 0 to 100, and as you increase the feed on the accelerator pedal, you're going to call for a certain amount of torque. It's called the driver's wish. So that's how much torque I would desire the engine to make. And you can see here the number, and then over here is the unit, foot-pounds. So for instance, at 1,000 RPM and 50% throttle, my driver's wish is 263 foot-pounds. Okay. Pretty straightforward map to understand. Let's take a look now at EFI Live and see how their map presents. It's important that you understand that the map that I showed you earlier was a 2010. This is a 2018, so the torque numbers are going to be different. And you can see the presentation of the map is slightly different also. The axis and the map data has been swapped. So instead of being a horizontal map, now we have a vertical map. Not a big deal, but here's the presentation. So again, 50% on the throttle, 1,200 RPM. Now we're commanding 370 Newton meters. And you know that because in the corner over here, we have Newton meters. So the units are presented over here. As you go to 100, 803 Newton meters, and so on for 100. I'll show you one more software package that's fairly typical to use with tuning Cummins trucks, and that's the Smarty UDC software. This software presents kind of similar to EFI Live in that the navigator is on the left, and you have a bunch of folders you can open. So I'll go to injection quantity, main injection quantity, and I'll look for my table that I want to edit, accelerator 1 to torque conversion. Now, interestingly, on the Smarty UDC software, we have 2 accelerator pedal to torque conversion tables. And this is the same tune that I opened in EFI Live. Now, this brings me to a point that I want to make, and that is that different software packages are going to have different degrees of map support. So you probably have 10,000 maps in the ECU. Not all of them you're going to be using for tuning. Maybe 100 of them, maybe more, maybe less. A lot of times the people who write the definitions for the software pick the maps that they think are going to be especially useful to you to use in tuning, and that's their selection of maps. Now, sometimes they get all the ones that you need, but most of the time, they might miss a few, and that's just the way it is. So different software packages are going to have different numbers of maps. Usually they're pretty close, but there'll be a little tweak here and there, and that's part of what makes some softwares better than others. But anyway, you can see the map presentation in Smarty UDC. Again, 50% on the throttle, 1200 RPM, 370 Newton meters. It really comes down to which software you start with, in my opinion, because the one you start with is the one you're going to learn, and then you're used to making the edits in there and you feel more comfortable in there, and that's just kind of how it goes. One of the kind of neat things I'll show you between the Smarty UDC and the EFI Live. So in Smarty, the nice thing about Smarty and the Cummins side is that they have these RTs, and RT means real time. And what that means is that you can make changes in the Smarty software in real time and while the truck's running. Now, neither EFI Live nor HP tuners offer that. It's a function that only Smarty offers, or that only the UDC software offers. So these little things, if you're tuning a truck on the dyno and you want to make steady state changes, the Smarty UDC software might be the software for you. My preference is the EFI Live scan tool. I think EFI Live's and HP Tuner's scan tool is a little bit stronger than the Smarty UDC. Again, just my personal preference. But you have to pick and choose, which parts of the software platform are more important to you and make your decision to buy the software based on that. Okay, so the next part of the tuning tool is the hardware. And the hardware is going to be an interface cable. And that interface cable is usually a USB cable. So it'll plug into USB and then into the ALDL or the OBD connector, and it's going to have some sort of proprietary chip on it that's going to check and make sure that you paid your licensing fee and that you're allowed to use the software that you purchased because you paid for the hardware fee. This is HP Tuners. This is EFI Live's V3. It's a USB cable to the box and then a cable from the box to the OBD port. Smarty's very similar, again, just an interface cable, that sort of thing. So that's how it goes as far as the software and the hardware goes. The next thing I want to go into is the data logging. So you have the scan tool, or you have the edit tool, which I just showed you here on the laptop. You have the hardware, and then you're going to have the data logger. And the data logger is going to be really important so you can get feedback from the truck, and you can look and see what changes you need to make, and are the changes that you're making in the editor really affecting the way the truck is running. So let's go ahead and make a dyno poll, and then we'll pull up a scan and take a look at the data logger and go through that. Okay, so we just made a nice pull on the dyno, 435 horsepower, 850 foot-pounds. The dyno is useful because it shows us the power curve of the engine, shows us torque, shows us when things start, when they fall off, but it doesn't tell us exactly what the truck is doing. And it also doesn't show us what's going on the street. So that's where a data logger can really come in handy. So when I'm considering buying a software package and I'm shopping data loggers, and I'm looking for the best data logger I can, I want the one that has the PIDs, that is the data. So PID is parameter identifier. So RPM would be a PID, throttle position would be a PID. I want the data logger that has the PIDs that interest me, and I want to have one that presents it in a way that makes the most sense to me. Now, my brain works on the chart program, so I like to have all the data laid out in front of me in kind of a streaming chart so I can see things. Your brain might not work that way, but mine does. Let's look at a data log for a Cummins truck and just see what I'm talking about when I'm considering a data logger. So a data logger is going to display chart data. So this chart displays an orange line, which I have my cursor on, which is RPM. And you can see RPM change as it goes through the run. You can see throttle position is constant at 100%. So that shows me that I'm asking the most out of the vehicle that I can. Over on the right-hand side, I have a couple PIDs. I have engine desired torque and I have engine actual torque. PIDs like this show me, what I'm asking out of the engine and what the engine's giving me. If there's a delta between actual and desired torque, well, that might be responsible for me not getting the performance out of the engine that I'm hoping for. The desired torque is going to lead to a desired fuel rate, and that desired fuel rate is going to be responsible for combusting with the prescribed amount of air to make that torque for me. If I'm not getting that desired amount of torque, well, I'm not going to get the desired amount of fuel rate, et cetera, et cetera. So something that I'm typically watching as I'm tuning a vehicle. Below here, in the next set of charts, I have actual and desired fuel rail pressure. You can see they're labeled here in fuel rail pressure desired, fuel rail pressure actual. The lines are blue and orange. They track relatively closely on top of each other, so you can't see them that well. But because they track relatively closely on top of each other, I know that the fuel system is performing like it's supposed to. So one of the things I'm always looking for as I'm tuning a diesel, especially for performance, is actual fuel rail pressure tracking with desired fuel rail pressure. Because if the truck's not getting the fuel pressure that it's desiring, there's no way we're going to be able to get the fuel volume that we desire, which means there's no way that we'll make the torque number or the horsepower number that we're desiring. Over on the right-hand side, main injection quantity, main injection US, that's microseconds of injector on time. So there's 3 elements of how much fuel you get to the engine. That is the nozzle size, how long the injector is on for, and then the pressure behind the injector. So if you know those 3 elements, you can, with relative certainty, know how much torque you should be getting out of the engine if you're getting efficient combustion. The number over here, main injection quantity, that's the fuel volume. So those 3 elements combine to make a fuel volume. That fuel volume mixes with the air mass. Those 2 things together are going to determine your air-fuel ratio. Again, how efficiently the engine's burning, and then how much torque it should be making. Let's drop down one more row. Turbo speed. So turbo shaft speed is going to show me how hard I'm working the turbocharger. You can see the orange line as I lean on the truck harder. As the RPM climbs, the turbo shaft speed climbs. From the start of the run, 100,000 RPM up to 122,000 RPM. So numbers like this are going to tell me, am I working within the safe speed of the turbocharger? Turbochargers are only designed to work at certain operating conditions. If the shaft speed is beyond the design limit of the turbocharger, well, we're going to lose reliability, durability. We want to avoid things like that. We're lucky that this Cummins engine is equipped with a turbo shaft speed sensor, and that this scan tool package allows us to data log that. So because we have those 2 things, we have some insight here that's really useful. We have exhaust pressure. Nice to see, because we can see the balance between exhaust pressure and boost pressure. If we know that balance between exhaust and boost pressure, we can see, again, how hard the turbocharger is working. Once we see that our drive pressure is much higher than our actual boost pressure, we know, hey, we're really working the turbocharger turbine side harder than we should be to get what we're wanting out of the compressor side. So these are PIDs that give us some indication of when we're getting to push the truck too hard. So is our drive pressure to boost pressure ratio going upside down on us, right? We want to avoid those types of things because reliability and durability concerns. And then below here, we have exhaust gas temperature 1, 2, 3, and 4. And I just posted those because it's interesting to see how exhaust gas temperature is high near the engine, before the turbocharger, which you can't see on this engine because there's no pyro pre-turbo. But the orange pyro is the exhaust gas temperature just after the turbocharger. And what I'll tell you, being in this business for a long time, is that the exhaust gas temperature post-turbocharger, when the turbocharger is working hard, is usually somewhere between 300 degrees Fahrenheit and 400 degrees Fahrenheit. As that temperature climbs, post-turbo, that immediate post-turbo, the other exhaust temperature probes downstream are going to see lesser degrees of that. And you can see that here as these lines drop as we go further and further downstream from the turbocharger. So EGT1, for instance, at 2,826 RPM, is 858, EGT2 752, EGT3 690, and EGT4 543. and that's not uncommon. Another thing these 4 probes are going to tell us is when the vehicle is in regeneration and how effective the regen mode is being. So emissions equipment is the reality of modern diesel engine tuning, and you're going to want to understand how regen works. These exhaust gas temperature probes are a window into that. They're going to show you how effectively the dosing system, the hydrocarbon dosing system, is getting the DPF up to temperature. Is it getting hot enough to burn off? It'll give you some sight, into when that's happening, and let you know kind of how that process is working. So if you can see that the delta temperature in front of the DPF is way higher than the delta temperature, or than the temperature after the DPF, you can kind of get this idea that the DPF might be face plugged, or that you might be at some risk of injuring the DPF. If you know those things, you can be a little gentler on the vehicle, or you can make decisions around that data. If you don't have a data logging system that gives you those PIDs, that gives you that really good data, you're not going to know that stuff, and you're not going to be able to know the truck as intimately as you should for a tuner. That's data logging 101. Of course, there's a lot more data out there. For instance, we like to put exhaust gas temperature probes in the manifolds. I love to have air-fuel ratio gauge, opacity meter if I can. The more instrumentation you can have, the better. Of course, all that instrumentation comes at a cost. If you need those things, great, spend money on them. If you don't, if you're just starting out, or if you have a truck that is at lower power or doesn't have an emission system, you're probably at less of a risk of injuring something. You can certainly start with fewer gauges. That's it in a nutshell. All these things you need to consider as you're jumping in and equipping yourself to take on your first diesel tuning job. In the next lesson, we're going to jump into a 2007 Dodge with some more horsepower and go through the tuning process in stages and see what making those changes actually does on the dyno, and review those changes in a log file.